Good morning, my dear friends. I'm Dr. Neha Bhatia, and today I'm going to talk about trigonometry in Vedic mathematics. Trigonometry is basically a branch of mathematics which deals or studies the relationship between the sides and angles of the right angle triangle. It has various applications in different fields like astronomy, electronics, physical sciences, navigation, etc. It is helpful in measuring the height of the building, towers, mountains, and also the distances between two rivers. So basically there are 6 trigonometric ratios. Let us consider a right angle triangle, okay, ABC, where C is the hypotenuse, A is the perpendicular and B is the base. So according to Pythagoras theorem, we have square of the hypotenuse is equal to the sum of the square of the other two sides, that is a square plus b square. And the 6 trigonometric ratios are given by where theta is the angle between AC and BC arms. So sin theta is perpendicular upon hypotenuse, which is A by C. Cos theta is base upon hypotenuse, which is B by C. Tan theta is perpendicular upon base, which is A by B. Cosecant theta is the reciprocal of sin theta, which is hypotenuse upon perpendicular. Secant theta is reciprocal of cos theta and is hypotenuse upon base. Cotangent theta or cot theta is the reciprocal of tan theta and this is base upon perpendicular. Let us apply the Vedic mathematic techniques to find the other trigonometric ratios basically with the given one. Okay, for example, if we have to find the value of sin 75, okay, or basically we have to find the value of cos 115 degree. So we can do so with the help of the techniques which I am going to discuss right now. So let us consider two right angle triangles with perpendicular P1, base P1, hypotenuse H1 and angle is theta 1, and another right angled triangle with perpendicular P2, base B2, hypotenuse H2 and angle being theta 2. Okay. So what is the formula? Let me write them. First, the given information, base, perpendicular and hypotenuse. So this is B1, B2, P1, P2, H1, H2 and let me write here the angles. This is theta 1 and theta 2. For calculating theta 1 plus theta 2, we have B1, B2 minus P1, P2, B1, P2 vertically crosswise, B1, P2 plus P1, B2 and just the product of the hypotenuse. For finding out theta 1 minus theta 2, we have B1, B2 plus P1 P2, and here it will be B1 P2 minus P1 B2 H1 H2 vertically. So there is vertically and crosswise. So basically we are using the sutra or the Tiriac technique or the method, which means vertically and crosswise. So using this technique, let us find out the values of some trigonometric ratios. Okay, let us take first example. We have sine theta, or basically theta at 30 degree. We know that sine 30 is half. So let me just write over here, this is 30 degree. Okay, 1 is the perpendicular, 2 is the hypotenuse. So this will become, with the help of Pythagoras theorem, the base will be, this will be 4 is equal to 1 plus b square. This is 3 is equal to b square. So b is root 3. So this is root 3, and we can consider another triangle with same base, hypotenuse and perpendicular. So this is the scenario. Let us calculate the value of sine 60, cos 60, tan 60, all the ratios using the Vedic technique. So this is base, perpendicular and hypotenuse 30 degree and 30 degree. So base is root 3, perpendicular is 1 in both the cases, and hypotenuse is 2. So 60, for 60 degree, when we are adding both the angles, we know base is what? Root 3 into root 3 is 3 minus 1, which is 2. For perpendicular, we have crosswise multiplication, root 3 plus root 3, see root 3 plus root 3, which is 2 root 3, and for hypotenuse we have just the product of the hypotenuse. So this will be 2 into 2, 4. For finding the difference, that is 30 minus 30, which is 0 degree, this will be root 3 into root 3 plus 1. So this will be 3 plus 1, 4. Okay. For perpendicular, it will be root 3 minus root 3, which is 0, and for the hypotenuse we just take the product. So this is 4 again. Now let me write all the trigonometric ratios. So this is sine 60. Just look from here. Sine 60 is perpendicular upon hypotenuse. So this is 2 root 3 upon 4, which is root 3 by 2. Cos 60 is, basically cos 60 degree is base upon hypotenuse, which is 2 upon hypotenuse is 4. So this is 1 by 2. Tan 60 is perpendicular upon base, which is 2 root 3 by 2, which is 3. Okay. Cosecant 60 degree is the reciprocal of sine 60. So this is 2 by root 3. Secant 60 degree is reciprocal of cos 60. So this is 2, and cot 60 degree is reciprocal of tan 60. So this is 1 by root 3. So in this manner we can calculate all the remaining, all the 6 trigonometric ratios, not the remaining, because 30 was given, and we, using the technique, we found out the values at 60-degree angle. Okay. Even if we can discuss about 0 degree, let us see what will be the result for 0 degree. See, for 0 sin 0, let me write here uh, what will be sin 0, cos 0 and so on. So, sin 0 is perpendicular upon hypotenuse, that is 0 by 4, which is 0. Cos 0 degree is base upon hypotenuse, which is 4 by 4, which is 1. Tan 0 degree is perpendicular upon base, which is 0 by 4. Oh, sorry, that is 0 only. Now, cosecant 0 degree is 1 by 0, which is infinity. Secant 0 degree is 1 again, reciprocal of 1 is 1, and cot 0 degree is infinity, that is not defined. Let us take another example. Say we have sine 45 degree as 1 by root 2. So, angle is 45 degree. 1 by root 2 is perpendicular is 1, okay, and hypotenuse is root 2, fine. So, what we can do is, we can take another triangle with the same measurements. Now, base will be, according to the Pythagoras theorem, this is 1 plus b square, let me write here. So, this will be 2 equal to 1 plus b square. So, this will be, b here is 1. So, let me write this information. So, this will be base, perpendicular and hypotenuse. So, this is, base is 1 1, angles are 45 degree each, perpendicular is again 1 1 and hypotenuse is root 2 each. So, now if we want to calculate sin 90, cos 90 and so on. So, what is the formula for the base? 1 into 1, which is 1, minus 1 into 1. So, this is 0. For the perpendicular we have 1 into 1 plus 1 into 1. So, this is 1 plus 1 2, and for hypotenuse we have just the product of the hypotenuse, which is 2. So, here we have sin 90 is perpendicular upon hypotenuse, which is 2 by 2 1, cos 90 degree is base upon hypotenuse 0 by 2, which is 0. Tan 90 degree is perpendicular upon base, which is not defined. Okay. Next is cosecant 90 degree, which is the reciprocal of sin 90, which is 1 again. Secant 90 degree is the reciprocal of cos 90 degree, so it is not defined. And for cot 90 degree, we have the reciprocal of tan 90, so it is 0. Okay. Let us take one more example where we are going to find the formulas for some of the trigonometric identities. Let us see how. So, let us take this as alpha, sin alpha, cos alpha, and we know that sin square alpha plus cos square alpha is 1. So, this will become 1. And for the other angle, we have cos beta, sin beta, and this is 1. An angle here is beta. Okay, let me write the given information. Base, perpendicular, and hypotenuse. So, base is cos alpha and this is cos beta. Angles here are alpha and beta. Perpendicular is sin alpha and sin beta, and hypotenuse are 1, 1 each. Okay. So, let us find alpha plus beta is cos alpha, cos beta minus sin alpha, sin beta. Okay. For perpendicular we have cos alpha, sin beta plus sin alpha, cos beta. And for hypotenuse we have the product of 1 with itself, which is 1. For alpha minus beta we have cos alpha, cos beta plus sin alpha, sin beta. For perpendicular we have cos alpha, sin beta minus sin alpha, cos beta. And for hypotenuse we just have to take the product of the given two hypotenuse. Now, if we want to find what is the formula for sin alpha plus beta, sin alpha minus beta, cos alpha plus beta, cos alpha minus beta, tan alpha plus beta, tan alpha minus beta, and so on. So, we can do so with the help of this information, and that will be very easy. So, sin alpha plus beta with the help of this technique is perpendicular upon hypotenuse. So, this is cos alpha sin beta plus sin alpha cos beta. Next, cos alpha plus beta is base upon hypotenuse. So, this is cos, remember here the denominator is 1. So, I am writing this as it is. Okay. So, for second we have cos alpha, cos beta minus sin alpha, sin beta upon 1, which is the formula itself. For tan alpha plus beta, okay, that is perpendicular upon base. So, this will become cos alpha sin beta plus sin alpha cos beta upon cos alpha cos beta minus sin alpha sin beta. Okay. So, in this manner we can find out the formulas as well. Let us see for sin alpha minus beta, cos alpha minus beta, and tan alpha minus beta. Okay. Let me write here only. So, sin alpha minus beta is, look at the second one. So, this is perpendicular cos alpha sin beta minus sin alpha cos beta upon 1. So, this is cos alpha sin beta minus sin alpha cos beta. Cos alpha minus beta is base upon hypotenuse, so that will be cos alpha cos beta plus sin alpha upon sin beta by 1, which is the numerator as it is. And for tan alpha minus beta, it is basically sin alpha minus beta upon cos alpha minus beta. Okay. Let us consider another example. Say we have alpha here, and I am taking perpendicular as sin alpha, base as base as again sin alpha only, cos alpha, and this is 1 with the help of the identity. And let me take another triangle with the same measurements. Okay. Now let us with the help of this example find the formula for sin 2 alpha, cos 2 alpha and tan 2 alpha. Okay. So given information is we have base as the angles are alpha alpha and the base are cos alpha cos alpha. Perpendicular is sin alpha sin alpha. Hypotenuse is 1 1 each. Okay. So now alpha plus alpha 2 alpha. So this will become, with the help of the formula, this will become cos alpha into cos alpha plus, in this case it is minus. So this is cos square alpha minus sin square alpha. Here in case of perpendicular it is cos alpha sin alpha plus sin alpha cos alpha. For the hypotenuse we just have 1 into 1 is 1. For 0 is cos square alpha plus sin square alpha, and this is cos alpha sin alpha minus sin alpha cos alpha, this is 0 and this will be 1. Okay, so we have this now. So now sin 2 alpha is perpendicular upon hypotenuse. Perpendicular here is, see, this is, here is 2 sin alpha cos alpha. So this is 2 cos alpha sin alpha. See, so we have got the formula. Okay, cos 2 alpha is base upon hypotenuse. So this is cos square alpha minus sin square alpha. And for finding out tan 2 alpha, so these are basically your half angle formulas. So this will be perpendicular. So let me write this here. So this is tan 2 alpha is perpendicular, which is 2 sin alpha cos alpha upon base cos square alpha minus sin square alpha. So in this manner we can find out the formulas, half angle formulas as well. Okay. So this is interesting. So let us take one more example. Say we have sin A as 3 by 5 and cos B as 8 by 70. Okay. So this is what? If A is the angle, this is perpendicular upon hypotenuse, which is 5, and this will be, base will be according to the Pythagoras theorem. So this will be what? 5 square is equal to 3 square plus b square, which is 25, equal to 9 plus b square. 25 minus 9 is 16, equal to b square, and this will be 4. So, this is 4. In this case, angle is B, this is base is 8 and hypotenuse is 17. Okay. So, we have to find the perpendicular. So, using the Pythagoras theorem, we have 17 square is p square plus 8 square. Okay. So, this is 17 square is 289 p square plus 64. See, here we can find the square also with the help of Vedic mathematic techniques. Okay. So, 289 minus 64 is p square. This is 1, 2, 5. Fine. So, this is p square. 17 square is 289 and so p is what? 15. So, p here is 15. So, we have this is 225, not 125. Find out. Okay, because 225 square root of 225 is 15. Again, that we can find with the help of Vedic techniques. So, we have perpendicular as 15. So, let us find out what will be sin A plus B, okay, or what will be cos A minus B. So, let me write this again. So, we have 3, 4, 5 A and we have 17, this is B, this is perpendicular is 15, right angle triangle and base is 8. Okay. So, what we have? We have perpendicular 3, base is 4 and hypotenuse is 5. Angle here is A. For the second we have angle as B, base is 8, perpendicular is 15 and hypotenuse is 17. Okay. So, let us now find out what is A plus B. Now, here A plus B is 32, 4 into 8 is 32 minus 45, which is minus 13. Okay. For perpendicular we have 4 into 15 plus 8 into 3, which is 60 plus 24, which is 84. And for the hypotenuse we have 17 into 5 is 85. Okay. For A minus B we have 4 into 8 32 plus 3 into 15 45. So, this will be 77. For perpendicular we have 4 into 15 minus 8 into 3. This is 60 minus 24. So, this is 36. And for hypotenuse again we have to take the product of 5 and 17, which is 85. Fine. Now, sine of A plus B is, our aim was to find the value of sine of A plus B and cos of A minus B. So, sine of A plus B is perpendicular, which is 84 upon hypotenuse, and cos of A minus B is base upon hypotenuse, which is 77 upon 85. So, in this manner we can find out the values of the remaining trigonometric ratios as well. I hope this method is useful, will be useful for you, and this is clear because this method is very easy to understand and apply. Okay? Thank you. Let us talk about the second sutra now, which we used for performing division. The sutra is Parvartraya Yogyat, which is applicable for the divisors which are closer to the base and they are more than the base. Let us take an example, let us take an illustration. For example, we have 432 divided by 11. Using this sutra, we follow the technique of complement. Okay. So, here if we see, dividend is 432, divisor is 11. 11 is closer to 10. Okay. And 11 is 1 more than 10. Okay. So, how are we going to do this? We are going to split the dividend into two parts, question part and the remainder part. And we are going to put a slash between the numbers. How? Just by looking that number of digits in the remainder part will be equal to the number of zeros in the base. Number of zeros in the base are 10, 10 is the base and number of zeros are 1. So, we are going to place the slash between 3 and 2. Okay. So, next is we are going to write here 11, 1 is the excess and the complement will be minus 1. Okay. So, how are we going to perform the division? We are going to carry down the 4 as it is. For the next step, we are going to multiply the first digit of the quotient part, this is the quotient part, with the new complement which is minus 1. So, 4 into minus 1 is minus 4. We are going to add this. This will become 3 minus 4 is minus 1. For next, again we are going to multiply minus 1 with minus 1 which is 2. Okay. And we are going to add this and this is going to form the remainder part. But this is not the final answer because we have minus here. Okay. So, how are we going to deal here? See, this is 40 minus 1. So, this will become 39. So, here quotient is 39 and remainder is 4. Okay. Let us take another example.